this function from getName to getHouse, I could change the implementation up here to be getHouse, and I can return not the student's name, but the student's house. And so now notice, if I run Python of students.py, enter, notice now it is sorted by house in reverse order. Slytherin is first, and then Gryffindor. If I get rid of the reverse, but keep the getHouse and rerun this program, now it's sorted by house. Gryffindor is first, and Slytherin is last. And the upside now of this is because I'm using this list of dictionaries and keeping the students' data together until the last minute when I'm finally doing the printing, I now have full control over the information itself, and I can sort by this or that. I don't have to construct those sentences in advance like I rather hackishly did the first time. All right, that was a lot. Let me pause here to see if there are questions.
So when we're sorting the files, should we use the loops, or like a dictionary or any kind of list? Can we sort by just sorting, not looping or any kind of stuff?
A good question. And the short answer with Python alone, you're the programmer, you need to do the sorting. With libraries and other techniques, absolutely. You can do more of this automatically because someone else has written that code. What we're doing at the moment is doing everything from scratch ourselves. But absolutely, with other functions or libraries, some of this could be made more easily done. Some of this could be made easier. Other questions on this technique here?
It equal to the returned value of the function. Can it be equal to just a variable or a value?
Well, yes, it should equal a value. So I'm specific, and I should clarify actually, since this was not obvious. So when you pass in a function like getName or getHouse to the sorted function as the value of key, that function is automatically called by the sorted function for you on each of the dictionaries in the list. And it uses the return value of getName or getHouse to decide what strings to actually use to compare in order to decide which is alphabetically correct. So this function, which you pass just by name, you do not pass in parentheses at the end, is called by the sorted function in order to figure out for you how to compare these same values.
How can we use nested dictionaries? Yani, I have read about nested dictionaries. What is the difference between nested dictionaries and dictionary inside a list? I think it is.
Sure. So we are using a list of dictionaries. Why? Because each of those dictionaries represents a student, and a student has a name and a house, and we want to, I claim, maintain that association. And it's a list of students because we've got multiple students, 4 in this case. You could create a structure that is a dictionary of dictionaries, but I would argue it just doesn't solve a problem. I don't need a dictionary of dictionary. I need a list of key value pairs right now. That's all. So let me propose if we go back to students.py here, and we revert back to the approach where we have getName as the function, both used and defined here, and that function returns the student's name. What happens, to be clear, is that the sorted function will use the value of key, getName in this case, calling that function on every dictionary in the list that it's supposed to sort. And that function getName returns the string that sorted will actually use to decide whether things go in this order, left, right, or in this order, right, left. It alphabetizes things based on that return value. So notice that I'm not calling the function getName here with parentheses. I'm passing it in only by its name so that the sorted function can call that getName function for me. Now, it turns out, as always, if you're defining something, be it a variable or in this case a function, and then immediately using it, but never once again needing the name of that function like getName, we can actually tighten this code up further. I can actually do this. I can get rid of the getName function altogether, just like I could get rid of a variable that isn't strictly necessary. And instead of passing key, the name of a function, I can actually pass key what's called a lambda function, which is an anonymous function, a function that just has no name. Why? Because you don't need to give it a name if you're only going to call it in one place. And the syntax for this in Python is a little weird, but if I do key equals literally the word lambda, then something like student, which is the name of the parameter I expect this function to take, and then I don't even type the return key. I instead just say student bracket name. So what am I doing here with my code? This code here that I've highlighted is equivalent to the getName function I implemented a moment ago. The syntax is admittedly a little different. I don't use def. I didn't even give it a name like getName. I instead am using this other keyword in Python called lambda, which says, hey, Python, here comes a function, but it has no name. It's anonymous. That function takes a parameter. I could call it anything I want. I'm calling it student. Why? Because this function that's passed in as key is called on every one of the students in that list, every one of the dictionaries in that list. What do I want this anonymous function to return? Well, given a student, I want to index into that dictionary and access their name so that the string Hermione and Harry and Ron and Draco is ultimately returned. And that's what the sorted function uses to decide how to sort these bigger dictionaries that have other keys like house as well. So if I now go back to my terminal window and run Python of students.py, it still seems to work the same, but it's arguably a little better designed because I didn't waste lines of code by defining some other function, calling it in one and only one place. I've done it all sort of in one breath, if you will. All right, let me pause here to see if there's any questions specifically about lambda or anonymous functions and this tightening up of the code.
And I have one question, like whether we could define lambda twice.
You can use lambda twice. You can create as many anonymous functions as you'd like, and you generally use them in contexts like this where you want to pass to some other function a function that itself does not need a name. So you can absolutely use it in more than one place. I just have only one use case for it. How about one other question on lambda or anonymous functions specifically?
What if our lambda would take more than one line, for example?
Sure, if your lambda function takes multiple parameters, that is fine. You can simply specify commas followed by the names of those parameters, maybe x and y or so forth, after the name student. So here too, lambda looks a little different from def in that you don't have parentheses, you don't have the keyword def, you don't have a function name, but ultimately they achieve that same effect. They create a function anonymously and allow you to pass it in, for instance, as some value here. So let's now change students.csv to contain not students' houses at Hogwarts, but their homes where they grew up. So Draco, for instance, grew up in Malfoy Manor. Ron grew up in the Burrow. Harry grew up in number 4 Privet Drive. And according to the internet, no one knows where Hermione grew up. The movies apparently took certain liberties with where she grew up. So for this purpose, we're actually going to remove Hermione because it is unknown exactly where she was born. So we still have some 3 students. But if anyone can spot the potential problem now, how might this be a bad thing? Well, let's go and try and run our own code here. Let me go back to students.py here, and let me propose that I just change my semantics because I'm now not thinking about Hogwarts houses, but the student's own home. So I'm just going to change some variables. I'm going to change this house to a home, this house to a home, as well as this one here. I'm still going to sort the students by name, but I'm going to say that they're not in a house, but rather from a home. So I've just changed the names of my variables in my grammar in English here ultimately to print out that, for instance, Harry is from number 4 Privet Drive and so forth. But let's see what happens here when I run Python of this version of students.py, having changed students.csv to contain those homes and not houses. Enter. Our first value error. Like the program just doesn't work. What might explain this value error, the explanation of which rather cryptically is too many values to unpack, and the line in question is this one involving split. How did all of a sudden, after all of these successful runs of this program, did line 5 suddenly now break?
In the line in students.csv, you have 3 values. There's a line that you have 3 values and students.
Yeah, I spent a lot of time trying to figure out where every student should be from so that we could create this problem for us. And wonderfully, like the first sentence of the book is number 4 Privet Drive. And so the fact that that address has a comma in it is problematic. Why? Because you and I decided some time ago to just standardize on commas, CSV, comma, separated values, to denote the we standardized on commas in order to delineate one value from another. And if we have commas grammatically in the student's home, we're clearly confusing it as this special symbol. And the split function is now, for just Harry, trying to split it into 3 values, not just 2. And that's why there's too many values to unpack, because we're only trying to assign 2 variables, name and house. Now, what could we do here? Well, we could just change our approach, for instance. Like, one paradigm that is not uncommon is to use something a little less common, like a vertical bar. So I could go in and change all of my commas to vertical bars. That too could eventually come back to bite us, in that if my file eventually has vertical bars somewhere, it might still break. So maybe that's not the best approach. I could maybe do something like this. I could escape the data, as I've done in the past, and maybe I could put quotes around any English string that itself contains a comma. And that's fine. I could do that, but then my code, students.py, is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes. And it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically. And so you know what? Why don't we see if there's a library in Python that exists to read and or write CSV files? Rather than reinvent a wheel, so to speak, let's see if we can write better code by standing on the shoulders of others who have come before us, programmers past, and actually use their code to do the reading and writing of CSVs, so we can focus on the part of our problem that you and I care about. So let's propose that we go back to our code here and see how we might use the CSV library. Indeed, within Python, there is a module called CSV. The documentation for it is at this URL here in Python's official documentation, but there's a few functions that are pretty readily accessible if we just dive right in. And let me propose that we do this. Let me go back to my code here, and instead of reinventing this wheel and reading the file line by line and splitting on commas and dealing now with quotes and privet drives and so forth, let's do this instead. At the start of my program, let me go up and import the CSV module. Let's use this library that someone else has written that's dealing with all of these corner cases, if you will. I'm still going to give myself a list, initially empty, in which to store all these students. But I'm going to change my approach here now just a little bit. When I open this file with with, let me go in here and change this a little bit. I'm going to go in here now and say this. Reader equals csv.reader, passing in file as input. So it turns out, if you read the documentation for the CSV module, it comes with a function called reader, whose purpose in life is to read a CSV file for you and figure out where are the commas, where are the quotes, where are all the potential corner cases, and just deal with them for you. You can override certain defaults or assumptions in case you're using not a comma, but a pipe or something else. But by default, I think it's just going to work. Now, how do I iterate over a reader and not the raw file itself? It's almost the same. The library allows you still to do this. For each row in the reader. So you're not iterating over the file directly now. You're iterating over the reader, which is, again, going to handle all of the parsing of commas and new lines and more. For each row in the reader, what am I going to do? Well, at the moment, I'm going to do this. I'm going to append to my students list the following dictionary. A dictionary that has a name, whose value is the current row's first column, and whose house, or rather home now, is the row's second column. Now, it's worth noting that the reader, for each line in the file, indeed returns to me a row. But it returns to me a row that's a list, which is to say that the first element of that list is going to be the student's name, as before. The second element of that list is going to be the student's home, as now before. But if I want to access each of those elements, remember that lists are 0 indexed. We start counting at 0 and then 1, rather than 1 and then 2. So if I want to get at the student's name, I use row bracket 0. And if I want to get at the student's home, I use row bracket 1. But in my for loop, we can do that same unpacking as before. If I know this CSV is only going to have 2 columns, I could even do this. For name home in reader, and now I don't need to use list notation. I can unpack things all at once and say name here and home here. The rest of my code can stay exactly the same, because what am I doing now on line 8? I'm still constructing the same dictionary as before, albeit for homes instead of houses. And I'm grabbing those values now, not from the file itself in my use of split, but the reader. And again, what the reader is going to do is figure out where are those commas, where are the quotes, and just solve that problem for you. So let me go now down to my terminal window and run Python of students.py and hit enter. And now we see successfully, sorted no less, that Draco is from Malform Manor, Harry is from number 4, comma, Privet Drive, and Ron is from the Borough. Questions now on this technique of using CSV Reader from that CSV module, which again is just getting us out of the business of reading each line ourselves and reading each of those commas and splitting.
So my questions are related to something a bit in the past. I recognize that you are reading a file every time we're assuming that we have the CSV file to hand already in this case. Is it possible to make a file readable and writable? So in case if you want, you could write some stuff to the file, but then at the same time you could have another function that reads through the file and does changes to it as you go along.
A really good question, and the short answer is yes. However, historically, the mental model for a file is that of a cassette tape. Years ago, not really in use anymore, but cassette tapes are sequential, whereby they start at the beginning, and if you want to get to the end, you kind of have to unwind the tape to get to that point. The closest analog nowadays would be something like Netflix or any streaming service where there's a scrubber that you have to go left to right. You can't just jump there or jump there. You don't have random access. So the problem with files, if you want to read and write them, you or some library needs to keep track of where you are in the file, so that if you're reading from the top and then you write at the bottom and you want to start reading again, you seek back to the beginning. So it's not something we'll do here in class. It's more involved, but it's absolutely doable. For our purposes, we'll generally recommend read the file, and then if you want to change it, write it back out rather than trying to make more piecemeal changes, which is good if, though, the file is massive and it would just be very expensive time-wise to change the whole thing. Other questions on this CSV Reader?
Is possible to write a paragraph in that file?
Absolutely. Right now I'm writing very small strings, just names or houses as I did before, but you can absolutely write as much text as you want. Indeed. Other questions on CSV Reader?
Can a user choose himself a key, like input key will be a name or home?
So short answer, yes. We could absolutely write a program that prompts the user for a name and a home, and we could write out those values. And in a moment, we'll see how you can write to a CSV file. For now, I'm assuming as the programmer who created students.csv that I know what the columns are going to be, and therefore I'm naming my variables accordingly. However, this is a good segue to one final feature of reading CSVs, which is that you don't have to rely on either getting a row as a list and using bracket 0 or bracket 1, and you don't have to unpack things manually in this way. We could actually be smarter and start storing the names of these columns in the CSV file itself. And in fact, if any of you have ever opened a spreadsheet file before, be it in Excel, Apple Numbers, Google Spreadsheets, or the like, odds are you've noticed that the first row very frequently is a little different. It actually is boldface sometimes, or it actually contains the names of those columns, the names of those attributes below. And we can do this here in students.csv. I don't have to just keep assuming that the student's name is first and that the student's home is second. I can explicitly bake that information into the file just to reduce the probability of mistakes down the road. I can literally use the first row of this file and say name, comma, home. So notice that name is not literally someone's name, and home is not literally someone's home. It is literally the words name and home separated by a comma. And if I now go back into students.py and don't use CSV Reader, but instead I use a dictionary reader, I can actually treat my CSV file even more flexibly, not just for this, but for other examples too. Let me do this. Instead of using a CSV Reader, let me use a CSV Dict Reader, which will now iterate over the file, top to bottom, loading in each line of text not as a list of columns, but as a dictionary of columns. What's nice about this is that it's going to give me automatic access now to those columns' names. I'm going to revert to just saying for row in reader. And now I'm going to append a name and a home. But how am I going to get access to the current row's name and the current row's home? Well, earlier I used bracket 0 for the first and bracket 1 for the second when I was using a reader. A reader returns lists. A dict reader or dictionary reader returns dictionaries, one at a time. And so if I want to access the current row's name, I can say row quote unquote name. I can say here for home, row quote unquote home. And I now have access to those same values. The only change I had to make, to be clear, was in my CSV file, I had to include on the very first row little hints as to what these columns are. And if I now run this code, I think it should behave pretty much the same, Python of students.py. And indeed, we get the same sentences. But now my code is more robust against changes in this data. If I were to open this CSV file in Excel or Google Spreadsheets or Apple Numbers and for whatever reason change the columns around, maybe this is a file that you're sharing with someone else, and just because they decide to sort things differently left to right by moving the columns around, previously my code would have broken because I was assuming that name is always first and home is always second. But if I did this, be it manually in one of those programs or here, home comma name, and suppose I reversed all of this. The home comes first, followed by Harry. The borough, then by Ron. And then lastly, Malfoy Manor, then Draco. Notice that my file is now completely flipped. The first column's now the second, and the second's the first, but I took care to update the header of that file, the first row. Notice my Python code, I'm not going to touch it at all. I'm going to rerun Python of students.py and hit enter, and it still just works. And this, too, is an example of like coding defensively. Like, what if someone changes your CSV file, your data file? Ideally, that won't happen. But even if it does now, because I'm using a dictionary reader that's going to infer from that first row for me what the columns are called, my code just keeps working. And so it keeps getting, if you will, better and better. Any questions now on this approach?
Yeah, what is the importance of new line in CSV file?
What's the importance of the new line in the CSV file? It's partly a convention. In the world of text files, we humans have just been for decades in the habit of storing data line by line. It's visually convenient. It's just easy to extract from the file because you just look for the new lines. So the new line just separates some data from some other data. We could use any other symbol on the keyboard, but it's just common to hit enter to just move the data to the next line. Just a convention. Other questions?
It seems to be working fine if you just have name and home. I'm wondering what will happen if you want to put in more data. Say you wanted to add the house to both the name and the home.
Sure, if you wanted to add the house back. So if I go in here and add house last, and I go here and say Gryffindor for Harry, Gryffindor for Ron, and Slytherin for Draco. Now I have 3 columns, effectively, if you will. Home on the left, name in the middle, house on the right, each separated by commas with weird things like number 4, comma, Privet Drive, still quoted. Notice if I go back to students.py and I don't change the code at all and run Python of students.py, it still just works. And this is what's so powerful about a dictionary reader. It can change over time. It can have more and more columns. Your existing code is not going to break. Your code would break, would be much more fragile, so to speak, if you were making assumptions like the first column's always going to be name. The second column's always going to be house. Things will break fast if those assumptions break down. So not a problem in this case. Well, let me propose that besides reading CSVs, let's at least take a peek at how we might write a CSV too. If you're writing a program in which you want to store not just students' names, but maybe their homes as well in a file, how can we keep adding to this file? Let me go ahead and delete the contents of students.csv and just re-add a single simple row, name, comma, home, so as to anticipate inserting more names and homes into this file. And then let me go to students.py and let me just start fresh so as to write out data this time. I'm still going to go ahead and import CSV. I'm going to go ahead now and prompt the user for their name. So input, quote unquote, what's your name, question mark. And I'm going to go ahead and prompt the user for their home. So home equals input, quote unquote, where's your home, question mark. Now I'm going to go ahead and open the file, but this time for writing instead of reading, as follows. With open, quote unquote, students.csv. I'm going to open it in append mode so that I keep adding more and more students and homes to the file rather than just overwriting the entire file itself. And I'm going to use a variable name of file. I'm then going to go ahead and give myself a variable called writer, and I'm going to set it equal to the return value of another function in the CSV module called csv.writer. And that writer function takes as its sole argument the file variable there. Now I'm going to go ahead and just do this. I'm going to say writer.writeRow, and I'm going to pass into writeRow the line that I want to write to the file, specifically as a list. So I'm going to give this a list of name, comma, home, which of course are the contents of those variables. Now I'm going to go ahead and save the file. I'm going to go ahead and rerun Python of students.py, hit enter, and what's your name? Well, let me go ahead and type in Harry as my name, and number 4, comma, privet drive. Enter. Now notice that input itself did have a comma, and so if I go to my CSV file now, notice that it's automatically been quoted for me so that subsequent reads from this file don't confuse that comma with the actual comma between Harry and his home. Well, let me go ahead and run it a couple of more times. Let me go ahead and rerun Python of students.py. Let me go ahead and input this time Ron and his home as the borough. Let's go back to students.csv to see what it looks like. Now we see Ron, comma, the borough has been added automatically to the file. And let's do one more. Python of students.py, enter. Let's go ahead and give Draco's name and his home, which would be Malfoy Manor. Enter. And if we go back to students.csv, now we see that Draco is in the file itself. And the library took care of not only writing each of those rows per the function's name, it also handled the escaping, so to speak, of any strings that themselves contained a comma, like Harry's own home. Well, it turns out there's yet another way we could implement this same program without having to worry about precisely that order again and again and just passing in a list. It turns out if we're keeping track of what's the name and what's the home, we could use something like a dictionary to associate those keys with those values. So let me go ahead and back up and remove these students from the file, leaving only the header row again, name, comma, home. And let me go over to students.py, and this time instead of using CSV writer, I'm going to go ahead and use csv.dictWriter, which is a dictionary writer that's going to open the file in much the same way, but rather than write a row as this list of name, comma, home, what I'm now going to do is follows. I'm going to first output an actual dictionary, the first key of which is name, colon, and then the value thereof is going to be the name that was typed in. And I'm going to pass in a key of home, quote unquote, the value of which, of course, is the home that was typed in. But with dictWriter, I do need to give it a hint as to the order in which those columns are when writing it out so that subsequently they could be read even if those orderings change. Let me go ahead and pass in field names, which is a second argument to dictWriter, equals, and then a list of the actual columns that I know are in this file, which of course are name, comma, home. Those times in quotes because that's indeed the string names of the columns, so to speak, that I intend to write to in that file. All right, now let me go ahead and go to my terminal window, run Python of students.py this time. I'll type in Harry's name again. I'll again type in number 4, comma, privet drive, enter. Let's now go back to students.csv, and voila, Harry's back in the file, and it's properly escaped or quoted. I'm sure then if we do this again with Ron and the borough, and let's go ahead and run it one third time with Draco and Malfoy Manor, enter. Let's go back to students.csv, and via this dictionary writer, we now have all 3 of those students as well. So whereas with CSV writer, the onus is on us to pass in a list of all of the values we want to put from left to right. With a dictionary writer, technically they could be in any order in the dictionary. In fact, I could just have correctly done this, passing in home followed by name, but it's a dictionary. And so the ordering in this case does not matter so long as the key is there and the value is there. And because I have passed in field names as the second argument to dictWriter, it ensures that the library knows exactly which column contains name or home, respectively. Are there any questions now on dictionary reading, dictionary writing, or CSVs more generally?
Is there any specific situation for me to use single quotation or double quotation? Because After the print, we use single quotation to represent the key of the dictionary. But after the reading or writing, we use the double quotation.
It's a good question. In Python, you can generally use double quotes or you can use single quotes, and it doesn't matter. You should just be self-consistent so that stylistically your code looks the same all throughout. Sometimes, though, it is necessary to alternate if you're already using double quotes, as I was earlier for a long f string. But inside that f string, I was interpolating the values of some variables using curly braces, and those variables were dictionaries. And in order to index into a dictionary, you use square brackets and then quotes. But if you're already using double quotes out here, you should generally use single quotes here or vice versa. But otherwise, I'm in the habit of using double quotes everywhere. Others are in the habit of using single quotes everywhere. It only matters sometimes if one might be confused for the other. Other questions on dictionary writing or reading?
Yeah, David. My question is, can we use multiple CSV files in any program?
Absolutely. You can use as many CSV files as you want, and it's just one of the formats that you can use to save data. Other questions on CSVs or file I/O?
Thanks for taking my question. So when you're reading from the file, you had the as a dictionary, you had the fields called. Couldn't you just call when you're reading? Couldn't you just call the row? In the previous version of the students .py file, when you're reading each row, you were splitting out the fields by name. Yeah. So when you're appending to the students list, can you just call for row in reader students.append row rather than naming each of the fields?
Oh, very clever. Short answer, yes. Insofar as dict_reader returns one dictionary at a time, when you loop over it, row is already going to be a dictionary. So yes, you could actually get away with doing this, and the effect would really be the same in this case. Good observation. How about one more question on CSVs?
Yeah, when reading in CSVs from my past work with data, a lot of things can go wrong. I don't know if it's a fair question that you can answer in a few sentences, but are there any best practices to double check that sort of no mistakes occurred?
It's a really good question, and I would say in general, if you're using code to generate the CSVs and to read the CSVs, and you're using a good library, theoretically, nothing should go wrong. It should be 100% correct if the libraries are 100% correct. You and I tend to be the problem. Like when you let a human touch the CSV, or when Excel or Apple Numbers or some other tools involved that might not be aligned with your code's expectations, things then, yes, can break. The goal really, sometimes, honestly, the solution is manual fixes. You go in and fix the CSV, or you have a lot of error checking, or you have a lot of try except just to tolerate mistakes in the data. But generally, I would say if you're using CSV or any file format internally to a program to both read and write it, you shouldn't have concerns there. You and I, the humans, are the problem, generally speaking, and not the programmers, the users of those files instead. All right, allow me to propose that we leave CSVs behind, but to note that they're not the only file format you can use in order to read or write data. In fact, they're a popular format, as is just raw text files, .txt files, but you can store data really any way that you want. We've just picked CSVs because it's representative of how you might read and write from a file, and do so in a structured way, where you can somehow have multiple keys, multiple values, all in the same file, without having to resort to what would be otherwise known as a binary file. So a binary file is a file that's really just zeros and ones, and they can be laid out in any pattern you might want, particularly if you want to store not textual information, but maybe graphical or audio or video information as well. So it turns out that Python is really good when it comes to having libraries for really everything. And in fact, there's a popular library called Pillow that allows you to navigate image files as well, and to perform operations on image files. You can apply filters a la Instagram. You can animate them as well. And so what I thought we'd do is leave behind text files for now and tackle one more demonstration, this time focusing on this particular library and image files instead. So let me propose that we go over here to VS Code. and create a program ultimately that creates an animated GIF. These things are everywhere nowadays in the form of memes and animations and stickers and the like. And an animated GIF is really just an image file that has multiple images inside of it. And your computer or your phone shows you those images one after another, sometimes on an endless loop, again and again. And so long as there's enough images, it creates the illusion of animation, because your mind and mine kind of fills in the gaps visually and just assumes that if something is moving, even though you're only seeing 1 frame per second or some sequence thereof, it looks like an animation. So it's like a simplistic version of a video file. Well, let me propose that we start with maybe a couple of costumes from another popular programming language. And let me go ahead and open up my first costume here, number 1. So suppose here that this is a costume, or really just a static image here, costume1.gif. And it's just a static picture of a cat, no movement at all. Let me go ahead now and open up a second one, costume2.gif, that looks a little bit different. Notice, and I'll go back and forth, this cat's legs are a little bit aligned differently, so that this was version 1. And this was version 2. Now, these cats come from a programming language from MIT called Scratch that allows you very graphically to animate all this and more. But we'll use just these 2 static images, costume 1 and costume 2, to create our own animated GIF that after this you could text to a friend or message them, much like any meme online. Well, let me propose that we create this animated GIF, not by just using some off-the-shelf program that we downloaded, but by writing our own code. Let me go ahead and run code of costumes.py and create our very own program that's going to take as input 2 or even more image files and then generate an animated GIF from them by essentially creating this animated GIF by toggling back and forth endlessly between those 2 images. Well, how am I going to do this? Well, let's assume that this will be a program called costumes.py that expects 2 command line arguments, the names of the files, the individual costumes that we want to animate back and forth. So to do that, I'm going to import sys so that we ultimately have access to sys.argv. I'm then, from this pillow library, going to import support for images specifically. So from PIL, import image, capital I, as per the library's documentation. Now I'm going to give myself an empty list called images, just so I have a list in which to store 1 or 2 or more of these images. And now let me do this. For each argument in sys.argv, I'm going to go ahead and create a new image variable, set it equal to this image dot open function passing in arg. Now, what is this doing? I'm proposing that eventually I want to be able to run Python of costumes.py and then as command line arguments specify costume1.gif space costume2.gif. So I want to take in those file names from the command line as my arguments. So what am I doing here? Well, I'm iterating over sys.argv, all of the words in my command line arguments. I'm creating a variable called image, and I'm passing to this function, image.open, from the pillow library, that specific argument. And that library is essentially going to open that image in a way that gives me a lot of functionality for manipulating it, like animating. Now I'm going to go ahead and append to my images list that particular image. And that's it. So this loop's purpose in life is just to iterate over the command line arguments and open those images using this library. The last line is pretty straightforward. I'm going to say this. I'm going to grab the first of those images, which is going to be in my list at location 0, and I'm going to save it to disk. That is, I'm going to save this file. Now, in the past, when we use CSVs or text files, I had to do the file opening. I had to do the file writing, maybe even the closing. I don't need to do that with this library. The Pillow library takes care of the opening, the closing, and the saving for me by just calling save. I'm going to call this save function, and just to leave space, because I have a number of arguments to pass, I'm going to move to another line so it fits. I'm going to pass in the name of the file that I want to create, costume.gif. That will be the name of my animated GIF. I'm going to tell this library to save all of the frames that I pass to it. So the first costume, the second costume, and even more if I gave them. I'm going to then append to this first image, the image is 0, the following images. Equals this list of images. And this is a bit clever, but I'm going to do this. I want to append the next image there, images 1. And now I want to specify a duration of 200 milliseconds for each of these frames, and I want this to loop forever. And if you specify loop equals 0, that is time 0, it means it's just not going to loop a finite number of times, but an infinite number of times instead. And I need to do one other thing. Recall that sys.argv contains not just the words I typed after my program's name, but what else does sys.argv contain? If you think back to our discussion of command line arguments, what else is in sys.argv besides the words I'm about to type, like costume1.gif and costume2?
Yeah, so we'll actually get in the original name of the program we want to run, the costumes.py.
Indeed, we'll get the original name of the program, costumes.py in this case, which is not a GIF, obviously. So remember that using slices in Python, we can do this. If sys.argv is a list, and we want to get a slice of that list, everything after the first element, we can do 1: which says start at location 1, not 0, and take a slice all the way to the end. So give me everything except the first thing in that list, which, to Mackenzie's point, is the name of the program. Now, if I haven't made any mistakes, let's see what happens. I'm going to run Python of costumes.py, and now I'm going to specify the two images that I want to animate. So costume1.gif and costume2.gif. What is the code now going to do? Well, to recap, we're using the sys library to access those command line arguments. We're using the pillow library to treat those files as images, and with all the functionality that comes with that library. I'm using this images list just to accumulate all of these images one at a time from the command line. And in lines 7 through 9, I'm just using a loop to iterate over all of them and just add them to this list after opening them with the library. And the last step, which is really just one line of code broken onto 3 so that it all fits, I'm going to save the first image, but I'm asking the library to append this other image to it as well. Not bracket 0, but bracket 1. And if I had more, I could express those as well. I want to save all of these files together. I want to pause 200 milliseconds, a fifth of a second, in between each frame. And I want it to loop infinitely many times. So now, if I cross my fingers as always, hit enter, nothing bad happened, and that's almost always a good thing. Let me now run code of costumes.gif to open up in VS Code the final image. And what I think I should see is a very happy cat. And indeed. So now we've seen not only that we can read and write files, be it textually, we can read and now write files that are binary, 0s and 1s. We've just scratched the surface. This is using the library called Pillow. But ultimately, this is going to give us the ability to read and write files however we want. So we've now seen that via file IO, we can manipulate not just textual files, be it TXT files or CSVs, but even binary files as well. In this case, they happen to be images, but if we dived in deeper, we could explore audio and video and so much more, all by way of these simple primitives, this ability somehow to read and write files. That's it for now. We'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on regular expressions. So a regular expression, otherwise known as a regex, is really just a pattern. And indeed, it's quite common in programming to want to use patterns to match on some kind of data, often user input. For instance, if the user types in an email address, whether to your program or a website or an app on your phone, you might ideally want to be able to validate that they did indeed type in an email address and not something completely different. So using regular expressions, we're going to have the newfound capability to define patterns in our code to compare them against data that we're receiving from someone else, whether it's just to validate it, or heck, even if we want to clean up a whole lot of data that itself might be messy because it too came from us humans. Before, though, we use these regular expressions, let me propose that we solve a few problems using just some simpler syntax and see what kind of limitations we run up against. Let me propose that I open up VS Code here, and let me create a file called validate.py. The goal at hand being to validate, how about just that, a user's email address. They've come to your app, they've come to your website, they type in their email address, and we want to say yes or no, this email address looks valid. All right, let me go ahead and type code of validate.py to create a new tab here. And then within this tab, let me go ahead and start writing some code. How about that keeps things simple initially? First, let me go ahead and prompt the user for their email address, and I'll store the return value of input in a variable called email, asking them, what's your email, ? I'm going to go ahead and preemptively at least clean up the user's input a little bit by minimally just calling strip at the end of my call to input, because recall that input returns a string or a stir. Stirs come with some built-in methods or functions, one of which is strip, which has the effect of stripping off any leading white space to the left or any trailing white space to the right. So that's just going to go ahead and at least avoid the human having accidentally typed in a space character. We're going to throw it away just in case. Now I'm going to do something simple. For a user's input to be an email address, I think we can all agree that it's got to minimally have an @ sign somewhere in it. So let's start simple. If the user has typed in something with an @ sign, let's very generously just say, OK, valid. Looks like an email address. And if we're missing that @ sign, let's say invalid, because clearly it's not an email address. It's not going to be the best version of my code yet, but we'll start simple. So I'm going to ask the question, if there is an @ symbol in the user's email address, go ahead and print out, for instance, quote unquote valid. Else, if there's not, now I'm pretty confident that the email address is in fact invalid. Now, what is this code doing? Well, if @ sign in email is a Pythonic way of asking, is this string, quote unquote @ in this other string, email, no matter where it is, at the beginning, the middle, or the end, it's going to automatically search through the entire string for you automatically. I could do this more verbosely, and I could use a for loop or a while loop and look at every character in the user's email address, looking to see if it's an @ sign. But this is one of the things that's nice about Python. You can do more with less. So just by saying if @ quote unquote in email, we're achieving that same result. We're going to get back true if it's somewhere in there, thus valid, or false if it is not. Well, let me go ahead now and run this program in my terminal window with Python of validate.py. And I'm going to go ahead and give it my email address, mailin@harvard.edu, enter. And indeed, it's valid. Looks valid, is valid. But of course, this program's technically broken. It's buggy. What would be an example input, if someone might like to volunteer an answer here, that would be considered valid, but you and I know it really isn't valid?
Yeah, thank you. Well, for instance, you can type just 2 signs and that's it, and it still be valid. Still be valid according to your program, but the same.
Exactly. We've set a very low bar here. In fact, if I go ahead and rerun Python of validate.py, and I'll just type in one @ sign, that's it. No username, no domain name. This doesn't really look like an email address, but unfortunately, my code thinks it in fact is, because it's obviously just looking for an @ sign alone. Well, how could we improve this? Well, minimally, an email address, I think, tends to have, though this is not actually a requirement, tends to have an @ sign and a single dot at least, maybe somewhere in the domain name. So mailin@harvard.edu. So let's check for that dot as well, though again, strictly speaking, doesn't even have to be that case. But I'm going for my own email address, at least for now, as our test case. So let me go ahead and change my code now and say not only if @ is an email, but also dot is in email as well. So I'm asking now 2 questions. I have 2 Boolean expressions, if @ in email, and I'm anding them together logically. This is a logical and, so to speak. So if it's the case that @ is in email and dot is in email, OK, now I'm going to go ahead and say valid. All right, this would still seem to work for my email address. Let me go ahead and run Python of validate.py, mailin@harvard.edu, enter. And that, of course, is valid as expected. But here, too, we can be a little adversarial and type in something nonsensical like @dot. And unfortunately, that, too, is going to be mistaken as valid, even though there's still no username, domain name, or anything like that. So I think we need to be a little more methodical here. In fact, notice that if I do this like this, the @ sign can be anywhere, and the dot can be anywhere. But if I'm assuming the user is going to have a traditional domain name like harvard.edu or gmail.com, I really want to look for the dot in the domain name only, not necessarily just the username. So let me go ahead and do this. Let me go ahead and introduce a bit more logic here and instead do this. Let me go ahead and do email.split of quote unquote @. So email again is a string or a stir. Strs come with methods not just strip, but also another one called split that, as the name implies, will split one stir into multiple ones if you give it a character or more to split on. So this is hopefully going to return to me two parts from a traditional email address, the username and the domain name. And it turns out I can unpack that sequence of responses by doing this. Username, comma, domain equals this. I could store it in a list or some other structure, but if I already know in advance what kinds of values I'm expecting, a username and hopefully a domain, I'm going to go ahead and do it like this instead and just define two variables at once on one line of code. And now I'm going to be a little more precise. If username, then I'm going to go ahead and say print valid. Else, I'm going to go ahead and say print invalid. Now, this isn't good enough, but I'm at least checking for the presence of a username now. And you might not have seen this before, but if you simply ask a question like if username, and username is a string, well, if username is going to give me a true answer if username is anything except none or quote unquote nothing. So there's a truthy value here whereby if username has at least one character, that's going to be considered true. But if username has no characters, it's going to be considered a false value effectively. But this isn't good enough. I don't want to just check for username. I want to also check that it's the case that dot is in the domain name as well. So notice here there's a bit of potential confusion with the English language. Here I seem to be saying if username and dot in domain, as though I'm asking the question if the username and the dot are in the domain, but that's not what this means. These are two separate Boolean expressions. If username and separately if dot in domain. And if I parenthesize this, we could make that even more clear by putting parentheses there, parentheses here. So just to be clear, it's really two Boolean expressions that we're anding together, not one longer English-like sentence. Now, if I go ahead and run this, Python of validate.py, enter, I'll do my own email address again, mailin@harvard.edu, and that's valid. And it looks like I could tolerate something like this. If I do mailin at just say Harvard, I think at the moment this is going to be invalid. Now maybe the top level domain Harvard exists, but at the moment it looks like we're looking for something more. We're looking for a top level domain too, like .edu. So for now, we'll just consider this to be invalid. But it's not just that we want to check for the presence of a username and the presence of a dot. Let's be more specific. Let's start to now narrow the scope of this program, not just to be about generic emails more generally, but about edu addresses. So specifically for someone in a US university, for instance, whose email address tends to end with .edu. I can be a little more precise, and you might recall this function already. Instead of just saying, is there a dot somewhere in domain, let me instead say, and the domain ends with, quote unquote, .edu. So now we're being even more precise. We want there to be minimally a username that's not empty. It's not just quote unquote nothing. And we want the domain name to actually end with .edu. Let me go ahead and run Python of validate.py. And just to make sure I haven't made things even worse, let me at least test my own email address, which does seem to be valid. Now, it seems that I minimally need to provide a username because we definitely do have that check in place. So I'm going to go ahead and say mailin. And now I'm going to go ahead and say @ and it looks like I could be a little malicious here, just say mailin at .edu, as though minimally meeting the requirements of this pattern. And that, of course, is considered valid, but I'm pretty sure there's no one at mailin at .edu. We need to have some domain name in there, so we're still not being quite as generous. Now, we could absolutely continue to iterate on this program, and we could add some more Boolean expressions. We could maybe use some other Python methods for checking more precisely. Is there something to the left of the dot, to the right of the dot? We could use split multiple times, but honestly, this just escalates quickly. Like, you end up having to write a lot of code just to express something that's relatively simple in spirit. Just format this like an email address. So how can we go about improving this? Well, it turns out in Python, there's a library for regular expressions. It's called succinctly RE. And in the RE library, you have a lot of capabilities to define and check for and even replace patterns. Again, a regular expression is a pattern, and this library, the RE library in Python, is going to let us to define some of these patterns, like a pattern for an email address, and then use some built-in functions to actually validate a user's input against that pattern, or even use these patterns to change the user's input or extract partial information therefrom. We'll see examples of all this and more. So what can and should I do with this library? Well, first and foremost, it comes with a lot of functionality. Here's the URL, for instance, to the official documentation. And let me propose that we focus on using one of the most versatile functions in the library, namely this, search. re.search is the name of the function in the RE module that allows you to pass in a few arguments. The first is going to be a pattern that you want to search for in, for instance, a string that came from a user. The string argument here is going to be the actual string that you want to search for that pattern. And then there's a third argument, optionally, that's a whole bunch of flags. A flag, in general, is like a parameter you can pass in to modify the behavior of the function. But initially, we're not even going to use this. We're just going to pass in a couple of arguments instead. So let me go ahead and employ this RE library, this regular expression library, and just improve on this design incrementally. So we're not going to solve this problem all at once, but we'll take some incremental steps. I'm going to go back to VS Code here, and I'm going to go ahead now and get rid of most of this code, but I'm going to go into the top of my file and first of all, import this RE library. So import RE gives me access to that function and more. Now, after I've gotten the user's input in the same way as before, stripping off any leading or trailing white space, I'm just going to use this function super trivially for now, even though this isn't really a big step forward. I'm going to say if re.search contains quote unquote @ in the email address, then let's go ahead and print valid. Else, let's go ahead and print invalid. At the moment, this is really no better than my very first version where I was just asking Python if @ in the email address. But now I'm at least beginning to use this library by using its own re.search function, which for now you can assume returns a true value effectively if indeed the @ is in email. Just to make sure that this version does work as I expect, let me go ahead and run Python of validate.py and enter. I'll type in my actual email address, and we're back in business. But of course, this is not great, because if I similarly run this version of the program and just type in an @, not an email address, and yet my code, of course, thinks it is valid. So how can I do better than this? Well, we need a bit more vocabulary in the realm of regular expressions in order to be able to express ourselves a little more precisely. Really, the pattern I want to ultimately define is going to be something like, I want there to be something to the left, then an @, then something to the right, and that something to the right should end with .edu, but should also have something before the .edu, like Harvard or Yale or any other school in the US as well. Well, how can I go about doing this? Well, it turns out that in the world of regular expressions, whether in Python or a lot of other languages as well, there are certain symbols that you can use to define patterns. At the moment, I've just used literal raw text. If I go back to my code here, this technically qualifies as a regular expression. I've passed in a quoted string inside of which is an @. Now, that's not a very interesting pattern. It's just an @, but it turns out that once you have access to regular expressions or a library that offers that feature, you can more powerfully express yourself as follows. Let me reveal that the pattern that you pass to re.search can take a whole bunch of special symbols, and here's just some of them. In the examples we're about to see, in the patterns we're about to define, here are the special symbols. You can use a single period, a dot, to just represent any character except a new line, a blank line. So that is to say, if I don't really care what letters of the alphabet are in the user's username, I just want there to be one or more characters in the user's name, dot allows me to express A through Z, uppercase and lowercase, and a bunch of other letters as well. Star is going to mean, in single asterisk, 0 or more repetitions. So if I say something star, that means that I'm willing to accept either 0 repetitions, that is nothing at all, or more repetitions, 1 or 2 or 3 or 300. If you see a plus in my patterns, that's going to mean 1 or more repetitions. That is to say, there's got to be at least one character there, one symbol, and then there's optionally more after that. And then you can say 0 or 1 repetition. You can use a single question mark after a symbol, and that will say I want 0 of this character or 1, but that's all I'll expect. And then lastly, there's going to be a way to specify a specific number of symbols. If you use these curly braces and a number, represented here symbolically as m, you can specify that you want m repetitions, be it 1 or 2 or 3 or 300. You can specify the number of repetitions yourself. And if you want a range of repetitions, like you want this few characters or this many characters, you can use curly braces and 2 numbers inside, called here m and n, which would be a range of m through n repetitions. Now, what does all of this mean? Well, let me go back to VS Code here, and let me propose that we iterate on this solution further. It's not sufficient to just check for the @ sign. We know that already. We minimally want something to the left and to the right. So how can I represent that? I don't really care what the user's username is or what letters of the alphabet are in it, be it Malin or anyone else's. So what I'm going to do to the left of this equal sign is I'm going to use a single period. The dot that, again, indicates any character except for a new line. But I don't just want a single character. Otherwise, the person's username could only be A at such and such or B at such and such. I want it to be multiple such characters, so I'm going to initially use a star. So dot star means give me something to the left, and I'm going to do another one, dot star something to the right. Now, this isn't perfect, but it's at least a step forward, because now what I'm going to go ahead and do is this. I'm going to rerun python to validate.py. I'm going to keep testing my own email address just to make sure I haven't made things worse, and that's now OK. I'm now going to go ahead and type in some other input, like how about just Malin @ with no domain name whatsoever. And you would think this is going to be invalid, but it's still considered valid. But why is that? If I go back to this chart, why is Malin @ with no domain now considered valid? What's my mistake here? By having used dot star at dot star as my regular expression or regex.
Because you're using the star instead of the plus sign?
Exactly. The star, again, means 0 or more repetitions. So re.search is perfectly happy to accept nothing after the @ sign, because that would be 0 repetitions. So I think I minimally need to evolve this and go back to my code here. And let me go ahead and change this from dot star to dot plus. And let me change the ending from dot star to dot plus, so that now when I run my code here, let me go ahead and run python of validate.py. I'm going to test my email address as always. Still working. Now let me go ahead and type in that same thing from before that was accidentally considered valid. Now I hit enter. Finally, it's invalid. So now we're making some progress on being a little more precise as to what it is we're doing. Now I'll note here, like with almost everything in programming, Python included, there's often multiple ways to solve the same problem. And does anyone see a way in my code here that I could make a slight tweak if I forgot that the plus operator exists and go back to using a star? If I allowed you only to use dots and only stars, could you recreate the notion of plus?
Yes, use another dot. Dot star.
Yeah, because if a dot means any character, we'll just use a dot. And then when you want to say or more, use another dot and then the star. So equivalent to dot plus would have been dot dot star, because the first dot means any character, and the second pair of characters, dot star, means 0 or more other characters. And to be clear, it does not have to be the same character. Just by doing dot or dot star does not mean your whole username needs to be A or AA or AAA or AAAA. It can vary with each symbol. It just means 0 or more of any character back to back. So I could do this on both the left and the right. Which one is better? You know, it depends. I think an argument could be made that this is even more clear, because it's obvious now that there's a dot, which means any character, and then there's the dot star. But if you're in the habit of doing this frequently, one of the reasons things like the plus exist is just to consolidate your code into something a little more succinct. And if you're familiar with seeing the plus, now maybe this is more readable to you. So again, just like with Python more generally, you're going to often see different ways to express the same patterns, and reasonable people might agree or disagree as to which way is better than another. Well, let me propose, too, that we can think about both of these models a little more graphically. If this looks a little cryptic to you, let me go ahead and rewind to the previous incarnation of this regular expression, which was just a single dot star. This regular expression, dot star at dot star, means what again? It means 0 or more characters followed by a literal @, followed by 0 or more other characters. Now, when you pass this pattern in as an argument to re.search, it's going to read it from left to right and then use it to try to match against the input, email in this case, that the user typed in. Now, how is the computer, how is re.search going to keep track of whether or not the user's email matches this pattern? Well, it turns out that it's going to be using a machine of sorts, implemented in software known as a finite state machine, or more formally, a non-deterministic finite automaton. And the way it works, if we depict this graphically, is as follows. The re.search function starts over here in a so-called start state. That's the sort of condition in which it begins. And then it's going to read the user's email address from left to right, and it's going to decide whether or not to stay in this first state or transition to the next state. So for instance, in this first state, as the user's reading my email address, maylin@harvard.edu, it's going to follow this curved edge up and around to itself, a reflexive edge. And it's labeled dot because dot, again, just means any character. So as the function is reading my email address, maylin@harvard.edu, from left to right, it's going to follow these transitions as follows. M, A, L, A, N. And then it's hopefully going to follow this transition to this second state, because there's a literal @ both in this machine as well as in my email address. Then it's going to try to read the rest of my address. HARVARD.edu, and that's it. And then the computer is going to check, did it end up in an accept state, a final state that's actually depicted here pictorially a little differently with double circles, one inside of the other. And that just means that if the computer finds itself in that second accept state, after having read all of the user's input, it is indeed a valid email address. If by some chance the machine somehow ended up stuck in that first state, which does not have double circles and it is therefore not an accept state, the computer would conclude this is an invalid email address instead. By contrast, if we go back to my other version of the code where I instead had ++ on both the left and the right, recall that re.search is going to use one of these state machines in order to decide from left to right whether or not to accept the user's input, like maylin@harvard.edu. Can we get from the start state, so to speak, to an accept state to decide, yep, this was, in fact, meeting the pattern? Well, let's propose that this non-deterministic finite automaton looked like this instead. We're going to start as before in the leftmost start state, and we're going to necessarily consume one character per this first edge, which is labeled with the dot to indicate that we can consume any one character, like the M in maylin@harvard.edu. Then we can spend some time consuming more characters before the @, so the A, L, A, N. Then we can consume the @. Then we can consume at least one more character, because recall that the regex has ++ this time. And then we can consume even more characters if we want. So if we first consume the H in harvard.edu, that then leaves the A, R, V, A, R, D, and then .edu. And now here too, we're at the end of the story, but we're in an accept state because that circle at the end has 2 circles total, which means that if the computer, if this function finds itself in that accept state after reading the entirety of the user's input, it is too, in fact, a valid email address. If by contrast, we had gotten stuck in one of those other states, unable to follow a transition, one of those edges, and therefore unable to make progress in the user's input from left to right, then we would have to conclude that that email address is, in fact, invalid. Well, how can we go upon improving this code further? Let me propose now that we check not only for a username and also something after the username, like a domain name, but minimally required that the string ends with .edu as well. Well, I think I could do this fairly straightforward. Not only do I want there to be something after the @, like the domain, like Harvard, I want the whole thing to end with .edu. But there's a little bit of danger here. What have I done wrong by implementing my regular expression now in this way by using .plus at .plus .edu? What could go wrong with this version?
The dot means something else in this context, where it means 0 or more repetitions of a character, which is why it will interpret it differently.
Exactly. Even though I mean for it to mean literally .edu, a period and then .edu, unfortunately in the world of regular expressions, dot means any character, which means that this string could technically end in AEDU or BEDU or CEDU and so forth, but that's not in fact that I want. So any instincts now as to how I could fix this problem? And let me demonstrate the problem more clearly. Let me go ahead and run this code here. Let me go ahead and type in maylin@harvard.edu. And as always, this does in fact work. But watch what happens here. Let me go ahead and do maylin@harvard and then maylin@harvard !edu, enter. That too is valid. So I could put any character there and it's still going to be accepted, but I don't want !edu. I want .edu literally. Any instincts then for how we can solve this problem here? How can I get this new function, re.search, and a regular expression more generally to literally mean a dot, might you think?
You can use the escape character, the backslash.
Indeed, the so-called escape character, which we've seen before outside of the context of regular expressions when we talked about new lines. \n was a way of telling the computer, I want a new line, but without actually literally hitting enter and moving the cursor yourself. And you don't want a literal n on the screen. So \n was a way to escape n and convey that you want a new line. It turns out regular expressions use a similar technique to solve this problem here. In fact, let me go into my regular expression. And before that final dot, let me put a single backslash. In the world of regular expressions, this is a so-called special sequence. And it indicates, per this backslash and a single dot, that I literally want to match on a dot. It's not that I want to match on any character and then edu. I want to match on a dot or a period edu. But we don't want Python to misinterpret this backslash as beginning an escape sequence, something special like \n, which even though we as the programmer might type 2 characters \n, it really is interpreted by Python as a single new line. We don't want any kind of misinterpretation like that here. So it turns out there's one other thing we should do for regular expressions like this that have a backslash used in this way. I want to specify to Python that I want this string, this regular expression in double quotes, to be treated as a raw string, literally putting an R at the beginning of the string to indicate to Python that you should not try to interpret any backslashes in the usual way. I want to literally pass the backslash and the dot and the edu into this particular function search in this case. So it's similar in spirit to using that f at the beginning of a format string, which of course tells Python to format the string in a certain way, plugging in variables that might be between curly braces. But in this case, R indicates a raw string that I want passed in exactly as is. Now, it's only strictly necessary if you are in fact using backslashes to indicate that you want some special sequence like \dot. But in general, it's probably a good habit to get into to just use raw strings for all of your regular expressions so that if you eventually go back in, make a change, make an addition, you don't accidentally introduce a backslash and then forget that that might have some special or misinterpreted meaning. Well, let me go ahead and try this new regular expression. I'll clear my terminal window, run Python of validate, run Python of validate.py, and then I'll type in my email address correctly, maylin@harvard.edu, and that's fortunately still valid. Let me clear my screen and run it one more time, Python of validate.py, and this time let's mistype it as maylin@harvard?edu, whereby there's obviously not a dot there, but there is some other single character that last time was misinterpreted as valid, but this time, now that I've improved my regular expression, it's discovered as indeed invalid. Any questions now on this technique for matching something to the left of the @, something to the right, and now ending with .edu explicitly?
What happens when a user enters multiple @?
A good question, and you kind of called me out here. Well, when in doubt, let's try. Let me go ahead and do Python of validate.py, maylin @harvard.edu, which also is incorrect. Unfortunately, my code thinks it's valid. So another problem to solve, but a shortcoming for now. Other questions on these regular expressions thus far?
Can you use curly brackets M instead of backslash?
Can you use curly brackets instead of backslash? Not in this case. If you want a literal dot, backslash dot is the way to do it literally. How about one other question on regular expressions?
Is this the same thing that Google Forms uses in order to categorize data? In, let's say, if you've got multiple people sending in requests about some feedback, do they categorize the data that they get using this particular regular expression thing?
Indeed, if you've ever used Google Forms to not just submit it, but to create a Google form, one of the menu options is for response validation, in English at least. And what that allows you to do is specify that the user has to input an email address or a URL or a string of some length. But there's an even more powerful feature that some of you may not have ever noticed. And indeed, if you'd like to open up Google Forms, create a new form temporarily, and poke around, you will actually see, in English at least, quote unquote regular expression mentioned as one of the mechanisms you can use to validate your user's input into your Google Forms. So in fact, after today, you can start avoiding these specific drop-downs of like email address or URL or the like, and you can express your own patterns precisely as well. Regular expressions can even be used in VS Code itself. If you go and find or do a find and replace in VS Code, you can, of course, just type in words like you could into Microsoft Word or Google Docs. You can also type, if you check the right box, regular expressions and start searching for patterns, not literally specific values. Well, let me propose that we now enhance this implementation further by introducing a few other symbols, because right now with my code, I keep saying that I want my email address to end with .edu and start with a username, but I'm being a little too generous. This does in fact work as expected for my own email address, mahlon@harvard.edu. But what if I type in a sentence like, my email address is mahlon@harvard.edu? And suppose I've typed that into the program, or I've typed that into a Google form. Is this going to be considered valid or invalid? Well, let's consider. It's got the @ sign, so we're good there. It's got one or more characters to the left of the @ sign. It's got one or more characters to the right of the @ sign. It's got a literal .edu somewhere in there to the right of the @ sign. And granted, there's more stuff to the right. There's literally this period at the end of my English sentence. But that's OK, because at the moment, my regular expression is not so precise as to say the pattern must start with the username and end with the .edu. Technically, it's left unsaid what more can be to the left and what more can be to the right. So when I hit Enter now, you'll see that that whole sentence in English is valid. And that's obviously not what you want. In fact, consider the case of using Google Forms or Office 365 to collect data from users. If you don't validate your input, your users might very well type in a full sentence or something else with a typographical error, not an actual email. So if you're just trying to copy all of the results that have been typed into your form so you can paste them into Gmail or some email program, it's going to break because you're going to accidentally paste something like a whole English sentence into the program instead of just an email address, which is what your mailer expects. So how can I be more precise? Well, let me propose we introduce a few more symbols as well. It turns out, in the context of a regular expression, one of these patterns, you can use the caret symbol, the little triangular mark, to represent that you want this pattern to match the start of the string specifically. Not anywhere, but the start of the user string. By contrast, you can use a $sign in your regular expression to say that you want to match the end of the string, or technically just before the new line at the end of the string. But for all intents and purposes, think of caret as meaning start of the string and $sign as meaning end of the string. It is a weird thing that one is a caret and one is a $sign. These are not really things that I think of as opposites, like a parenthesis or something like that. But those are the symbols the world chose many years ago. So let me go back to VS Code now, and let me add this feature to my code here. Let me specify that, yes, I do want to search for this pattern, but I want the user's input to start with this pattern and end with this pattern. So even though it's going to start looking even more cryptic, I put a caret symbol here at the beginning, and I put a $sign here at the end. That does not mean I want the user to type a caret symbol or a $sign. This is special symbology that indicates to re.search that it should only look for now an exact match against this pattern. So if I now go back to my terminal window, and I'll leave the previous result on the screen, let me type the exact same thing. My email address is mahlon@harvard.edu, period. And now I'm going to go ahead and hit Enter. Now that's considered invalid. But let me clear the screen, and just to make sure I didn't break things, let me type in just my email address, and that too is valid. Any questions now on this version of my regular expression, which note goes further to specify even more precisely that I want it to match at the start and the end? Any questions on this one here?
Okay, you have slash and .edu, and then the $sign. But the dot is like one of the regular expression, right?
It normally is, but this backslash that I deliberately put before this period here is an escape character. It is a way of telling re.search that I don't want any character there. I literally want a period there. And it's the only way you can distinguish one from the other. If I got rid of that slash, this would mean that the email address just has to end with any character, then an E, then a D, then a U. I don't want that. I want literally a period, then the E, then the D, then the U. This is actually common convention in programming and technology in general. If you and I decide on a convention whereby we're using some character on the keyboard to mean something special, invariably we create a future problem for ourselves when we want to literally use that same character. And so the solution in general to that problem is to somehow escape the character so that it's clear to the computer that it's not that special symbol, it's literally the symbol it sees.
So we don't need another slash before the $sign?
No, because in this case, $sign means something special. Per this chart here, $sign by itself does not mean US dollars or currency. It literally means match the end of the string. If, however, I wanted the user to literally type in a $sign at the end of their input, the solution would be the same. I would put a backslash before the $sign, which means my email address would have to be something like mailin@harvard.edu $sign, which is obviously not correct too. So backslashes just allow you to tell the computer to not treat those symbols specially, like meaning something special, but to treat them literally instead. How about one other question here on regular expressions?
You said one represents to make it 1 plus. Then you said 1 was to make it 1 with nothing.
Sure.
So
let me rewind in time. I think what you're referring to was one of our earlier versions that initially looked like this, which just meant 0 or more characters, then an @sign, then 0 or more other characters. We then evolved that to be this, dot plus on both sides, which means 1 or more characters on the left, then an @sign, then 1 or more characters on the right. And if I'm interpreting your question correctly, one of the points I made earlier was that if you didn't use plus or forgot that it exists, you could equivalently achieve the exact same result with 2 dots and a star. Because the first dot means any character. It's got to be there. The second dot star means 0 or more other characters. And same on the right. So it's just another way of expressing the same idea. 1 or more can be represented like this with dot dot star. Or you can just use the handier syntax of dot plus, which means the same thing. All right, so I dare say there's still some problems with the regular expression in this current form, because even though now we're starting to look for the username at the beginning of the string from the user, and we're looking for the .edu literally at the end of the string from the user, those dots are a little too encompassing right now. I am allowed to type in more than the single @sign. Why? Because @ is a character, and dot means any character. So honestly, I can have as many @signs as this thing at the moment as I want. For instance, if I run python of validate.py, mailin@harvard.edu still works as expected. But if I also run python of validate.py and incorrectly do mailin @ harvard.edu, that should be invalid, but it's considered valid instead. So I think we need to be a little more restrictive when it comes to that dot. And we can't just say, oh, any old character there is fine. We need to be more specific. Well, it turns out that regular expressions also support this syntax. You can use square brackets inside of your pattern. And inside of those square brackets, include 1 or more characters that you want to look for specifically. Alternatively, you can, inside of those square brackets, put a caret symbol, which unfortunately in this context means something completely different from match the start of the string. But this would be the complement operator inside of these square brackets, which means you cannot match any of these characters. So things are about to look even more cryptic now, but that's why we're focusing on regular expressions on their own here. If I don't want to allow any character, which is what a dot is, let me go ahead and I could just say, well, I only want to support A or B's or C's or D's or E's or F's or G's. I could type in the whole alphabet here, plus some numbers to actually include all of the letters that I do want to allow. But honestly, a little simpler would be this. I could use a caret symbol and then an @sign, which has the effect of saying, this is the set of characters that has everything except an @sign. And I can do the same thing over here. Instead of a dot, to the right of the @sign, I can do open bracket, caret, @. And I admit, things are starting to escalate quickly here, but let's start from the left and go to the right. This caret outside of the square brackets at the very start of my string, as before, means match from the start of the string. And let's jump ahead. The $sign all the way at the end of the regular expression means match at the end of the string. So if we can mentally tick those off as straightforward, let's now focus on everything else in the middle. Well, to the left here, we have new syntax, a square bracket, another caret, an @ and a closed square bracket, and then a plus. The plus means the same thing as always. It means one or more of the things to the left. What is the thing to the left? Well, this is the new syntax. Inside of square brackets here, I have a caret symbol and then an @. That just means any character except an @. It's a weird syntax, but this is how we can express that simple idea. Any character on the keyboard except for an @. And heck, even other characters that aren't physically on your keyboard, but that nonetheless exist. Then we have a literal @. Then we have another one of these same things. Square bracket, caret, closed bracket, which means any character except an @, then one or more of those things, followed by literally a period edu. So now let me go ahead and do this again. Let me rerun Python of validate.py and test my own email address to make sure I've not made things worse, and we're good. Now let me go ahead and clear my screen and run Python of validate.py again and do mailin @harvard.edu, crossing my fingers this time, and finally, this now is invalid. Why? I'm allowing myself to have one @ in the middle of the user's input, but everything to the left, per this new syntax, cannot be an @. It can be anything but one or more times. And everything to the right of the @ can be anything but an @ one or more times, followed by, lastly, a literal .edu. So again, the new syntax is quite simply this. Square brackets allow you to specify a set of characters that you literally type out at your keyboard, A, B, C, D, E, F, or the complement, the opposite, the caret symbol, which means not, and then the one or more symbols you want to exclude. Questions now on this syntax here?
So right after @, can we use the curly brackets M1 so that we can only have one repetition of the symbol?
Absolutely. So we could do this. Let me go ahead and pull up VS Code and let me delete the current form of a regular expression and go back to where we began, which was just .* and $. I could absolutely do something like this and require that I want at least one of any character here. And then I could do something more to have any more as well. So the curly brace syntax, which we saw on the slide earlier but didn't yet use, absolutely can be used to specify a specific number of characters. But honestly, this is more verbose than is necessary. The best solution, arguably, or the simplest at least ultimately, is just to say .+. But there too, another example of how you can solve the same problem multiple ways. Let me go back to where the regular expression just was and take other questions as well. Questions on these sets of characters or complementing that set?
So can you use that same syntax to say that you don't want a certain character throughout the whole string?
You could. It's going to be, you could absolutely use the same character to exclude you could absolutely use this syntax to exclude a certain character from the entire string, but it would be a little harder right now because we're still requiring .edu at the end. But yes, absolutely. Other questions?
What happens if the user inputs .edu in the beginning of the string?
A good question. What happens if the user types in .edu at the beginning of the screen? Well, let me go back to VS Code here, and let's try to solve this in two different ways. First, let's look at the regular expression and see if we can infer if that's going to be tolerated. Well, according to the current cryptic regular expression, I'm saying that you can have any character except the @, so that would work. I could have the dot for the .edu, but then I have to have an @. So that wouldn't really work, because if I'm just typing in .edu, we're not going to pass that constraint. So now let me try this by running the program. Let me type in just literally .edu. That doesn't work. But, I could do this, .edu @.edu. That too is invalid. But let me do this, .edu @something.edu. That passes. So it's starting to get a little weird now. Maybe it's valid, maybe it's not, but I think we'll eventually be more precise too. How about one more question on this regular expression? and these complementing of sets.
Can we use another domain name as a string input?
Can you use another domain name? Absolutely. I'm using my own just for the sake of demonstration, but you could absolutely use any domain or top-level domain. And I'm using .edu, which is very US-centric, but this would absolutely work exactly the same for any top-level domain. All right, let me go ahead now and propose that we improve this regular expression further, because if I pull it up again in VS Code here, you'll see that I'm being a little too tolerant still. It turns out that there are certain requirements for someone's username and domain name in an email address. There is an official standard in the world for what an email address can be and what characters can be in it. And this is way too accommodating of all of the characters in the world except for the @ symbol. So let's actually narrow the definition of what we're going to tolerate in usernames, and companies like Gmail could certainly do this as well. Suppose that it's not just that I want to exclude @signs. Suppose that I only want to allow for, say, characters that normally appear in words, like letters of the alphabet A through Z, be it uppercase or lowercase, maybe some numbers, and heck, maybe even an underscore could be allowed too. Well, we can use this same square bracket syntax to specify a set of characters as follows. I could do A, B, C, D, E, F, G, H, I, J. Oh my God, this is going to take forever. I'm going to have to type out all 26 letters of the alphabet, both lowercase and uppercase. So let me stop doing that. There's a better way already. If you want to specify within these square brackets a range of letters, you can actually just do a hyphen. If you literally do A-Z in these square brackets, the computer is going to know you mean A through Z. You do not need to type 26 letters of the alphabet. If you want to include uppercase letters as well, you just do the same. No spaces, no commas. You literally just keep typing A through capital Z. So I have little a hyphen little z, big A hyphen big Z. No spaces, no commas, no separators. You just keep specifying those ranges. If I additionally want numbers, I could do 0, 1, 2, 3, 4. Nope, you don't need to type in all 10 decimal digits. You can just say 0 through 9 using a hyphen as well. And if you now want to support underscores as well, which is pretty common in usernames for email addresses, you can literally just type an underscore at the end. Notice that all of these characters are inside of square brackets, which just again means here is a set of characters that I want to allow. I have not used a caret symbol at the beginning of this whole thing because I don't want to complement it with an E, not complement it with an I. I don't want to complement it by making it the opposite. I literally want to accept only these characters. I'm going to go ahead and do the same thing on the right. If I want to require that the domain names similarly come from this set of characters, which admittedly is a little too narrow, but it's familiar for now, so we'll keep it simple. I'm going to go ahead and paste that exact same set of characters over there to the right. And so now it's much more restrictive. Now I'm going to go ahead and run python of validate.py. I'm going to test my own email address, and we're still good. I'm going to clear my screen and run it once more. This time trying to break it, let me go ahead and do something like, how about David_Malan at harvard.edu, enter. But that too is going to be valid. But if I do something completely wrong again, like Malan at harvard.edu, that's still going to be invalid. Why? Because my regular expression currently only allows for a single @ in the middle, because everything to the left must be alphanumeric, alphabetical or numeric, or an underscore, the same thing to the right, followed by the .edu. Now, honestly, this is a regular expression that you might be in the habit of typing in the real world. As cryptic as this might look, this is the world of regular expressions. So you'll get more comfortable with this syntax over time. But thankfully, some of these patterns are so common that there are built-in shortcuts for representing some of the same information. That is to say, you don't have to constantly type out all of the symbols that you want to include, because odds are some other programmer has had the same problem. So built into regular expressions themselves are some additional patterns you can use. And in fact, I can go ahead and get rid of this entire set, A through Z lowercase, A through Z uppercase, 0 through 9, and an underscore, and just replace it with a single \W. \W in this case represents a word character, which is commonly known as a alphanumeric symbol or the underscore as well. I'm going to do the same thing over here. I'm going to highlight the entire set of square brackets, delete it, and replace it with a single \W. And now I feel like we're making progress because even though it's cryptic, and would have looked way cryptic a little bit ago, and even though it would have looked even more cryptic a little bit ago, now it's at least starting to read a little more friendly. This caret on the left means start matching at the beginning of the string. \w means any word character. The plus means one or more. @ symbol literally. Then another word character, one or more. Then a literal dot, then literally edu, and then match at the very end of the string, and that's it. So there's more of these too, and we won't use them all here, but here is a partial list of the patterns you can use within a regular expression. One, you have \d for any decimal digit. Decimal digit meaning 0 through 9. Commonly done here too is if you want to do the opposite of that, the complement, so to speak, you can do \D, which is anything that's not a decimal digit. So it might be letters and punctuation and other symbols as well. Meanwhile, \S means white space characters, like a single hit of the space, or maybe hitting tab on the keyboard. That's white space. \S is the opposite or complement of that, anything that's not a white space character. \W we've seen, a word character, as well as numbers and the underscore. And if you want the complement or opposite of that, you can use \W to give you everything but a word character. Again, these are just common patterns that so many people were presumably using in yesteryear that it's now baked into the regular expression syntax so that you can more succinctly express your same ideas. Any questions then on this approach here, where we're now using \W to represent my word character?
So what I want to ask about was the actually the previous approach, like the square bracket approach. Could we accept like lists in there?
Yes, we'll see this before long. But suppose you wanted to tolerate not just .edu, but maybe .edu or .com. You could do this. You could introduce parentheses, and then you can OR those together. I could say com or edu. I could also add in something like, in the US, or gov, or net, or anything else, or org, or the like. And each of the vertical bars here means something special. It means or, and the parentheses simply group things together. Formally, you have this syntax here. A or B, A or vertical bar B means A has to match or B has to match, where A and B can be any other patterns you want. In parentheses, you can group those things together. So just like math, you can combine ideas into one phrase and do this thing or the other. And there's other syntax as well that we'll soon see. Other questions on these regular expressions and this syntax here?
What if we put spaces in the expression?
Sure. So if you want spaces in there, you can't use \W alone, because that is only a word character, which is alphabetical, numerical, or the underscore. But you could do this. You could go back to this approach whereby you use square brackets, and you could say A through Z, or A through Z, or 0 through 9, or underscore, or I'm going to hit the space bar, a single space. You can put a literal space inside of the square brackets, which will allow you then to detect a space. Alternatively, I could still use \W, but I could combine it as follows. I could say, give me a \W or a \S, because recall that \S is white space, so it's even more than a single space. It could be a tab, but by putting those things in parentheses, now you can match either the thing on the left or the thing on the right one or more times. How about one other question on these regular expressions?
Perfect. So I was going to ask, does the \W include a dot? Because no.
Nope,
Okay.
it only includes letters, numbers, and underscore. That is it.
And I was wondering, you gave an example at the beginning that had spaces, like this is my email, so and so. I don't think our current version, even quite a long while ago, stopped accepting it. Was that because of the caret, or because of something else?
No, the reason I was handling spaces and other English words when I typed out my email address as mailin@harvard.edu was because we were using initially .* or .+, which is any character. And even after that, we said anything except the @ sign, which includes spaces. Only once I started using square brackets and A through Z and 0 through 9 and underscore did we finally get to the point where we would reject white space. And in fact, I can run this here. Let me go into the current version of my code in VS Code, which is using, again, the \W's for word characters. Let me run python validate.py and incorrectly type in something like, my email address is maylin@harvard.edu, period, which has spaces to the left of my username. And that is now invalid because space is not a word character. Yorgo notes, too, that technically I'm not allowing dots. And some of you might be thinking, wait a minute, my Gmail address has a dot in it. That's something we're going to still have to fix. A \W is not the end all here. It's just allowing us to express our previous solution a little more succinctly. Now, one thing we're still not handling quite properly is uppercase versus lowercase. The \W technically does handle lowercase letters and uppercase because it's the exact same thing as that set from before, which had little a through little z and big A through big Z. But watch this. Let me go ahead in my current form run python validate.py, and just because my caps lock key is down, maylin@harvard.edu, shouting my email address, it's going to be OK in terms of the Maylin. It's going to be OK in terms of the Harvard because those are matching the \W, which does include lowercase and uppercase, but I'm about to see invalid. Why? Why is maylin@harvard.edu invalid when it's in all caps here, even though I'm using \W?
Yeah, so you are asking for the domain.edu in lowercase, and you're typing it in uppercase.
Exactly. I'm typing in my email address in all uppercase, but I'm looking for literally .edu. And as I see you with AirPods and so many of you with headphones, I apologize for yelling into my microphone just now to make this point. But let's see if we can't fix that. Well, if my pattern on line 5 is expecting it to be lowercase, there's actually a few ways I can solve this. One would be something we've seen before. I could just force the user's input to all lowercase. And I could put onto the end of my first line .lower and actually force it all to lowercase. Alternatively, I could do that a little later. Instead of passing in email, I could pass in the lowercase version of email because email addresses should, in fact, be case insensitive. So that would work too. But there's another mechanism here, which is worth seeing. It turns out that that function before, called re.search, supports, recall, a third argument as well, these so-called flags. And flags are configuration options, typically to a function, that allow you to configure it a little differently. And how might I go about configuring this call to re.search a little bit differently insofar as I'm currently only passing in 2 arguments? Well, it turns out that some of the flags you can pass into this function are these. It turns out that the regular expression library in Python, aka RE, comes with a few built-in variables, so to speak, things that you can think of as constants that have meaning to re.search, and they do so as follows. If you pass in as a flag re.ignore case, what re.search is going to do is ignore the case of the user's input. It can be uppercase, lowercase, a combination thereof. The case is going to be ignored. It will be treated case insensitively. And you can do other things, too, that we won't do here. But if you want to handle the user's input that maybe spans multiple lines, maybe they didn't just type in an email address, but an entire paragraph of text, and you want to match different lines of that text, that is multiple lines, another flag is for re.multi-line for just that, or re.all, whereby you can configure the dot to recognize not just any character except new lines, but any character plus new lines as well. But for now, let me go ahead and just make use of this first one. Let me pass in a third argument to re.search, which is re.ignore case. Let me now rerun the program without clearing my screen, python validate.py. Let me type in again in all caps, effectively shouting maylin@harvard.edu, enter, and now it's considered valid because I'm telling re.search specifically to ignore the case of the input, and that too here is fine. And why might I do this approach rather than call .lower in one of those other locations? If I don't actually want to change the user's input for whatever reason, I can still treat it case insensitively without actually changing the value of that variable itself. All right, any final questions now on this validation of email addresses?
So the pattern is a string, right?
Mm-hmm.
Can we use an F string?
You can. Yes, you can use an F string so that you could plug in, for instance, the value of a variable and pass it into the function. Other questions on this?
\w character, could we take it as an input from the user?
Technically, yes. That's not a problem we're trying to solve right now. We want the user to provide literal input, like their email address, not necessarily a regular expression. But you could imagine building software that asks the user, especially if they're more advanced users, to type in a regular expression for some reason to validate something else against that. And in fact, that's what Google's doing. If you play around with Google Forms and create a form with response validation and select regular expression, Google lets you and I type in our own regular expressions, which would be a perfect example of that. All right, well, let me propose that we try to solve one other problem here, whereby if I go into the same version as before, which is now ignoring case, but I type in one of my other email addresses. Let me go ahead and run python of validate.py, and this time let me type in not mailin@harvard.edu, which I use primarily, but another email address of mine, mailin@cs50.harvard.edu, which forwards to the same. Let me go ahead and hit enter now, and invalid. Even though I'm pretty sure that is, in fact, my email address. Well, let's put our finger on the reason why. Why at the moment is mailin@cs50.harvard.edu being considered invalid, even though I'm pretty sure I send and receive email from that address too? Why might that be?
Because there is a dot that has come after the @ symbol.
Exactly. There's a dot after my CS50, and I'm not expecting any dots there. I'm expecting only, again, word characters, which is A through Z, 0 through 9, and underscore. So I'm going to have to retool here. But how could I go about doing this? Well, it turns out, theoretically, there could be other email addresses, even though they'd be getting a little excessively long. For instance, mailin@something.cs50.harvard.edu, which does not technically exist, but it could. You can have, of course, multiple dots in a domain name like we see here. Wouldn't it be nice if we could handle that as well? Well, let me propose that we modify my regular expression as follows. It turns out that you can group ideas together. And you can not only ask whether or not this pattern matches or this one, using syntax like A vertical bar B, which means either A or B. You can also group things together and then apply some other operator to them as well. In fact, let me go back to VS Code here, and let me propose that if I want to tolerate a subdomain like CS50 that may or may not be there, let me go ahead and change it as follows. I could naively do this. If I want to support subdomains, I could say, well, let's allow for other word characters plus, and then a literal dot. And notice, I'll highlight in blue here what I've just added. Everything else is the same, but I'm now adding room for another sequence of one or more word characters and then a literal dot. So this now, I think, if I rerun python of validate.py, will work for mailin@cs50.harvard.edu, enter. Unfortunately, does anyone see where this is going? Let me rerun python of validate.py and type in, as I keep doing, mailin@harvard.edu, which up until now has kept working despite all of my changes. But now, finally, I've broken my own email address. So logically, what's the solution here? Well, there's a bunch of ways we could solve this. I could maybe start using two regular expressions and support email addresses of the form username@domain.tld or username@subdomain.domain.tld, where TLD just means top-level domain like edu. Or I could maybe just modify this one, because I'd prefer not to have like two regular expressions or one that's twice as big. Why don't I just specify to re.search that part of this pattern is optional? What was the symbol we saw earlier that allows you to specify that the thing before it is technically optional?
The straight bar. We are using the straight bar as optional, make the argument optional.
So we could use a vertical bar and some parentheses and say either there's something here or there's nothing. We could do that in parentheses, but I think there's actually an even easier way.
Actually, is a question mark.
Indeed, question mark. Think back to this summary here of our first set of symbols, whereby we had not just dot and star and plus, but also a question mark, which means literally 0 or 1 repetitions, which effectively means optional. It's either there, 1, or it's not, 0. Now, how can I translate to this code here? Well, let me go ahead and surround this part of my pattern with parentheses, which doesn't mean I want literally a parenthesis in the user's input. I just want to group these characters together. And in fact, this now will still work. I've only added parentheses around the new part for the subdomain. Let me run python of validate.py. Let me run mailin at cs50.harvard.edu, enter. That's still valid. But to be clear, if I rerun it again for mailin at harvard.edu, that is still invalid. But not if I go in here and say after the parentheses, which now is one logical unit, it's one big group of ideas together, I add a single question mark there. This will now tell re.search that that whole thing in parentheses can either be there once or be there not at all, 0 times. So what does this translate into when I run it? Well, let me go ahead and rerun it with mailin at cs50.harvard.edu so that the subdomain's there. That works as before. Let me clear my screen and run it again. Python of validate.py with mailin at harvard.edu, which used to work, then broke. Are we back in business now? We are. That's now valid again. Questions now on this approach where we've used not just the question mark, but the parentheses as well.
Okay, yeah, you said it works for 0 or 1 repetition. What if you have more?
What if you have more? That's OK. That's where you could do star. Star is 0 or more, which gives you all the flexibility in the world.
Yeah, so I was just asking that with question mark, there's only one repetition allowed.
It means 0 or 1 repetition. So it's either not there or it is there. And so that's why this pattern now, if I go back to my code, even though, again, it admittedly looks cryptic, let me highlight everything after the @ sign and before the $sign. This now represents a domain name, like harvard.edu, or a subdomain within the domain name. Why? Well, this part to the right is the same as always. \w+ means something like Harvard or Yale. \edu means literally .edu. So the new part is this. In parentheses, I have another set of \w+, \dot now, but it's all in parentheses. I'm now having a question mark right after that, which means that whole thing in parentheses either can be there or it can't be there. It's either of those that are acceptable. So a question mark effectively makes something optional. It would not be correct to remove the parentheses, because what would this mean? If I remove the parentheses, that would mean that only this dot is optional, which isn't really what we want to express. I want the subdomain, like CS50, and the additional dot to be what's there or not there. How about one other question on regexes here?
Can they use this for the usernames?
Absolutely. We still have other problems, right? We're not solving all of the problems today just yet, but absolutely. Right now, we are not letting you have a period in your username. And again, some of you with Gmail accounts or other accounts, you probably have not just underscores, numbers, and letters. You might have periods too. Well, we could fix that. Not using question mark here per se, but now that we have these parentheses at our disposal, what I could do is this. I could use parentheses to surround the \w to say any word character, which is the same thing again as a letter or a number or an underscore. But I could also or in, using a vertical bar, something else, like a literal dot. Now, a literal dot needs to be escaped. Otherwise, it represents any character, which would be a regression, a step back. But now notice what I've done. In parentheses, I'm telling re.search that those first few characters in your email address, that is your username, has to be a word character, like A through Z, uppercase or lowercase, or 0 through 9, or an underscore, or a literal dot. We could do this differently too. I could get rid of the parentheses and the or, and I could just use a set of characters. I could, again, manually say A through Z, 0 through 9, underscore, and then I could do a literal dot with a \, period. And now I technically don't even need the uppercase, because I'm already telling the computer to ignore case. I can just pick one or the other. Which one is better is really up to you. Whichever one you think is more readable would generally be the better design. All right, let me propose that I rewind this in time to where we left off, which was here. And let me propose that there are indeed still limitations of this solution, not just with the username, not just with the domain name. We're still being a little too restrictive. So would you like to see the official regular expression that at least browsers use nowadays whenever you type in an email address to a web form and the web form, the browser tells you yes or no, your email address is syntactically valid? Ready? Ready? Here is, and this isn't even officially the right regular expression. It's a simplified version that browsers use because it catches most mistakes, but not all. Here we go. This is the regular expression for a valid email address, at least as browsers nowadays implement them. Now, it's crazy cryptic at first glance, but note, and it's wrapping onto many lines, but it's just one pattern. But just notice the now familiar symbols. There is the caret symbol at the very top. There is the $sign at the very end. There is a square bracket over here, and then some of these ranges plus other characters. Turns out you don't normally see these characters in email addresses. It looks like you're swearing at someone in their username. But they're valid characters. They're valid officially. That doesn't mean that Gmail is going to allow you to put $signs and other punctuation in your username, but officially some servers might allow that. So if you really want to validate a user's email address, you would actually come up with or copy paste something like this. But honestly, this looks so cryptic, and if you were to type it out manually, you are so likely to make a mistake. What's the better solution here instead? This is where, per past weeks, libraries are your friend. Surely someone else on the internet, a programmer more experienced than you even, has come up with code that validates email addresses properly using this regular expression or even something more sophisticated than that. So generally, if the problem at hand is to validate input that is pretty conventional, an email address, a URL, something where there's an official definition that's independent of you yourself, find a popular library that you're comfortable using and use it in your code to validate email addresses. This is not a wheel necessarily that you yourself should invent. We've used email addresses, though, to iteratively start from something simple, too simple, and build on top of that. So you could certainly imagine using regular expressions still to validate things that aren't email addresses, but are data that are important to you. So we at least now have these building blocks. Now, besides the regular expressions themselves, it turns out there's other functions in Python's RE library for regular expressions. Among them is this function here, re.match, which is actually very similar to re.search, except you don't have to specify the caret symbol at the very beginning of your regex if you want to match from the start of a string. re.match by design will automatically start matching from the start of the string for you. Similar in spirit is re.fullmatch, which does the same thing, but not only matches at the start of the string, but the end of the string, so that you too don't need to type in the caret symbol or the $sign as well. But let's go ahead and transition back now to some actual code whereby we solve a different problem in spirit. Rather than just validate the user's input and make sure it looks the way we want, let's just assume that the users are not going to type in data exactly as we want, and so we're going to have to clean up their input. This happens so often when you're using like a Google form or Office 365 form or anything else to collect user input. No matter what your form question says, your users are not necessarily going to follow those directions. They might go ahead and type in something that's a little differently formatted than you might like. Now, you could certainly go through the results and download a CSV or open the Google spreadsheet or equivalent in Excel and just clean up all of the data manually. But if you've got lots of submissions, dozens, hundreds, thousands of rows in your data set, doing things manually might not be very fun. It might be much more effective to write code, as in Python, that can allow you to clean up that data and any future data as well. So let me propose that we go ahead here and close validate.py, and let's go ahead and create a new program altogether called format.py, the goal of which is to reformat the user's input in the format we expect. I'm going to go ahead and run code of format.py, and let's suppose that the data we're going to reformat is the user's name. So not email address, but name this time. And we're going to hope that they type in their name properly, like David Malan. But some users might be in the habit, for whatever reason, of typing their name backwards, if you will, with a comma, such as Malan, comma, David instead. Now, it's fine because both are clearly as readable to the human, but if you want to standardize how those names are stored in your system, perhaps a database or CSV file or something else, it would be nice to at least standardize or canonicalize the format in which you're storing your data so that if you print out the user's name, it's always the same format, David Malan, and there's no commas or backwardsness to it. So let's go ahead and do something familiar. Let's go ahead and give myself a variable called name and set it equal to the return value of input, asking the user, as we've done many times, what's your name, ? I'm going to go ahead and proactively at least clean up some messiness, as we keep doing here, by just stripping off any leading or trailing white space, just in case the user accidentally hits the space bar. We don't want that ultimately in our data set. And now let me go ahead and do this, as we've done before. Let me just go ahead quickly and print out, just to make sure I'm off to the right start, hello, and then in curly braces, name. So making an F string to format hello, name. Now, let me go ahead and clear my screen and run Python of format.py. Let me behave and type in my name as I normally would.